Okay, so I am gone off to OMAC. Yeah, lucky me, huh? So anyway, today's lesson, we already pretty much know it. We're going to be talking today specifically about trig inverse, okay? So when you see like sine inverse, cosine inverse, or tangent inverse, or any of them, you're going to be finding an angle. Okay, now let's take a look at the reading real quick. So if I backtrack to the reading, take a look at the reading, here's what we had. So, give me a second, where did my pen go? So, if I take a look at this, we've done this before. So the domain is from -1 to 1. So if I take a look at the sine graph, sure enough, we know on the unit circle, if we look at the unit circle, 1 to -1. So that makes sense on the domain. And the range, we know that we always want to find the angle closest to 0, and that's why it puts us from -pi-halves to pi-halves, okay? Cosine's the same way, height of -1 to 1. We know that we're always looking for the angle closest to 0, so we find our angles from 0 to pi, okay? Now tangent, it's undefined at -pi-halves, asymptote, and at pi-halves, asymptote, and you're going to find the angles either in this quadrant, down here, quadrant 4 is negative angles, or in this angle, okay? So we've done this before. That's in our reading. So let's go ahead and take a look at our examples, okay? Now, it says arc sine. Now, that's kind of weird for you, but if you look at the unit circle, if I take a look at the arc sine, really, of -1/2, so -1/2 is going to be down here for the y value, right? So the length of this arc is the same as the angle. So we get -pi4. And so we're looking at the arc length for -1/2, which is going to be -pi6. Except for one thing, because it's an arc length, we're going to change this one to positive pi6, okay? Secant, well, we know secant, same thing as 1 over cosine, so we're going to write this as cosine inverse of 1 over -2, okay? So look at the unit circle, looking at the unit circle, -1/2 for cosine is all the way over at 2 pi3. So we go 2 pi3. Now, if we need it in terms of degrees for dummies, we'll make this one be a 30 degrees. I'll let this one be in terms of degrees, which is 120 degrees, okay? And finally, cotangent inverse of square root of 3. So we know that cotangent is the inverse of tangent. So we'll rewrite as tangent inverse of 1 over the square root of 3. If you do some rationalization, multiply by the square root of 3 over square root of 3, we're looking for tangent inverse of square root of 3 over 3. And of course, you guys know how to rationalize. Multiply by the square root of 3 over square root of 3. So tangent inverse of square root of 3 over 3, if I need it in terms of degrees, and I want to positive square root of 3 over 3, it is at 30 degrees, okay? So this is all just unit circle stuff, okay? We've done this. We're pretty good at this, okay? Now, example 2, with a calculator, degrees. So first of all, let's go degree mode, right? So let's go degree mode. So my calculator, let's check it out. Let's check my mode. Degree mode, okay, I'm good. So I've got cosine of theta equals 0.87. If I'm looking for the angle, I want to find the angle. Cosine of what angle? So I'm going to do the cosine inverse of 0.87, all right? So if I go cos inverse of 0.87, and I get an answer about 29.5 degrees. So theta is equal to 29.5 degrees, right? An illustration, because it's always like to illustrate so you know what's going on. Think about your unit circle, okay? And if I'm looking for an x value of about 0.87, so this is 1, 0.87 might be about here. What angle would that refer to? Right about there, so that's my angle, about 29.5 degrees. So if I have an x value of about 0.87, what angle does that refer to? About 29.5. That's really what's going on. Okay, now cosecant. So cosecant's not our calculator, but we know that sine is. So we're going to do the sine inverse of 1 over -2.3. Okay, so I'm just going to use my calculator. Again, I'm going to go just simply do this, scoot it over so you can see it clear. I'll go sine inverse of 1 divided by negative 2.3, and I get an answer about negative 25 degrees, okay? So theta is about a negative 25.77 degrees. Again, we've done this, we've done all of this before, except we've done it in terms of radians. Now we're doing it for degrees, for dummies, but we can do that, okay? All right, example 3. So if we're going to solve this triangle, we need to do it, if it's a triangle, we do need to do it in terms of degrees, because it is a triangle. We're not going to measure triangle angles, plus that's 90, so we already know we're in degrees. So first of all, let's find angle A. So to find angle A, if I need to find angle A, let's figure out what the name of these sides are. That's my opposite side, and that's my hypotenuse. So if I look up on the board behind me, opposite, hypotenuse, right? Opposite, hypotenuse, it's got to be sine. So it says take sine of theta equals the opposite of the hypotenuse, okay? But we don't want sine of theta, we want sine of A. So I'm going to rewrite this as sine of A is equal to the 8 over 17, opposite of hypotenuse. But if I need to find the angle, I need to use the inverse button, okay? So to find the inverse button, I'm just going to go sine inverse of 8 17. So if I need to find the angle, now to give me angle A. If I need to find the angle, I'm going to do this sine inverse, okay, clear. Sine inverse 8 divided by 17. I got about 28.1 degrees, okay? So angle A, the measure of angle A is about 28.1 degrees. Okay, again, if you need the angle, you have to use the inverse button. We know that. We've done this lots of times. Okay, I'm going to put a 28.1 here. So angle C is easy. Angle C, the measure of angle C is just going to be 90 minus 28.1. I can do that. Just use my calculator, right? And so if I go just then my 90 minus my 28.1, I get about 61.9. So the measure of angle C is about 61.9. Got it, okay? So far so good. Now if I want to find little c, right, that's angle C, that's little c. If I want to find little c, let's just use Pythagoras theorem. That seems like the easiest way to do it. You could use sine or cosine or tangent, but I'm going to go straight to just doing 8 squared plus c squared equals 17 squared, right? Pythagoras theorem. I'll bring over the 8 squared. C squared is equal to 17 squared minus 8 squared. Let me use my calculator to get that. So clear, I'm going to go 17 squared minus 8 squared. 225, so I'll take the square root of 225, which is 15. Yep, there it is, 15. So C, little c is 15. How's that? You guys learned this in geometry? You'll learn this in algebra too, so this should just be a nice little easy review, okay? I am going to turn the page. Ready? Go. All right. Oh, a story problem. I don't mind a story problem. Okay. So, example 4. A 40-foot ladder rests against a building where the base of the ladder is 6 feet from the base of the building. Find the angle between the top of the ladder and the side of the building. So let's draw a picture. So here's my building. Okay. And here's my ladder. And I know it's a 40-foot ladder. And I know that it's 6 feet from the base of the ladder to the building. Okay, I'm going to assume a right angle. I'm going to assume they built that straight up at 90. Okay, so I want the angle between the top of the ladder and the side of the building. So I want this angle here. Let's call it theta. Okay. So if I want that angle, let's figure out what these sides are. So from the angle, always take it from the angle. That's my opposite side. That's my hypotenuse. If I look up behind me, opposite hypotenuse is sine. So I get sine theta equals opposite, which is 6, over hypotenuse, which is 40. So 6 over 40, okay? Again, if I'm looking for the angle, I need to use the inverse button. Okay, so I'm just going to go sine inverse of 6 over 40. And let's use our calculator, degree mode, obviously. Obviously degree mode. Let's go sine inverse 6 divided by 40. I get an angle of about 8.6 degrees, which is good. It should be a small angle, otherwise we're going to fall over, right? So theta is about 8.6 degrees. Okay, easy. Okay, example 5. Cosine sine inverse of that, draw a triangle. Well, let's draw a triangle. It says draw a triangle, let's draw a triangle. So let's draw a right triangle. So when I see this symbol, this little -1, it means angle, right? So let me put some angle here, call it theta, okay? So if that's theta, then sine is always equal to the opposite over the hypotenuse, right? So that means this side, opposite over hypotenuse, this side must be 3, that's the opposite side. And the 5 would have to go here for the hypotenuse. Now, let's check it out. If I need to cosine it, I need the adjacent side. So I'm just going to use Pythagorean theorem. That's easy. We'll call that B for now, or A. How about A for Pythagorean theorem? So we'll go A squared plus 3 squared equals 5 squared. And of course, hopefully you guys know about a 3, 4, 5 right triangle. So if you do the Pythagorean theorem, A is going to be 4. 3, 4, 5 triangle. So if A is 4. Now it's easy. I want the cosine of this, adjacent over hypotenuse. So the answer's got to be 4 over 5. Okay? How's that? Okay, example 6. Same thing, except we're going to do things in terms of x. So it gets a little bit tricky because we're going to do Pythagorean theorem, but with the x term. But let's build a triangle first, okay? So it says build a triangle. All right, I can build a triangle. I'll go slowly. Right triangle. Let's put theta here, okay? Now, what do I know about cosine? Cosine is the same thing as adjacent over hypotenuse, okay? So I need a fraction. I've got x. Let's make it x over 1. Okay, I'll stop. I need to make this x over 1 because I need a fraction. I need my adjacent over my hypotenuse. So cosine is always adjacent over hypotenuse, so I've got x. How about x over 1? So in terms of x, the adjacent is x, and the hypotenuse is 1. Okay? So cosine's adjacent over hypotenuse. So I put that in the wrong spot. Yes, I did. Somebody say, Mr. Davies, you made a mistake. It's okay, I fixed it. We're all good. There we go. We white this out. Doggone, I hate it when I make mistakes. Even on film, worst of all, okay? So, there we go. So I've got my adjacent, which is x, over my hypotenuse is 1. So now let's find out what this side is. Let's do Pythagorean theorem. Okay, so we'll call this b for now. So I'll go x squared plus b squared equals 1 squared. If I bring over the x squared, because I want to solve for b, b squared is equal to 1 minus x squared. Right, 1 squared is 1. I'm going to take the square root of both sides. B is going to equal plus or minus the square root of 1 minus x squared. Okay, so one more time. I set up Pythagorean theorem. I want x squared plus b squared equals 1 squared. X squared plus b squared equals 1 squared. To solve for b, I brought over the 1. I brought over the x squared, so I've got 1 minus x squared. Take the square root of both sides. Now it says plus or minus, but it has to be plus because we've got a length. It can't be negative, okay? Because we're going to length, so I'm going to get rid of the negative. So this turns out to be the square root of 1 minus x squared. Now it's kind of hard, kind of weird right now, but if we want the sine of this, we have all our sides. We really do. We have the adjacent side, we have the opposite side, and we have the hypotenuse. So the sine of any angle is always equal to the opposite of the hypotenuse. So now it's pretty easy. Opposite is going to be this square root of 1 minus x squared, and the hypotenuse is 1, and that's our answer in terms of x. You're going to need to know how to do this when you get to calculus, right? So homework for today. Here it is, page 506, 6, 8, 10, 18, 25, 30, 38, 40, and 41. Let's get busy. Put the cell phones away. Period.